So check this out. We know that the distance traveled is the area under the velocity curve. We also know from last semester that velocity is the derivative of distance. So it turns out that this relationship works for other kinds of functions too. If we find the area under a rate of change curve, a derivative curve, then we can find how much the original quantity changed over usually an input period. So here's an example. I have a graph here, and it's the rate at which cola is produced at some cola production factory. Has nothing to do with distance, has nothing to do with velocity, but it's a rate of change. It's the rate at which cola is produced. So this I see didn't print with all the information you might expect. It's written in the words though. So the production rate is given in thousands of gallons per hour, and time is measured in hours across the input axis, in this case the x-axis. To the nearest round number, approximately how many thousands of gallons of cola were produced that day. So I haven't been given a graph of how much cola there is. I've been given a graph of the rate at which cola is produced, and I'm going to use the area under the curve to figure out how much cola got produced. So this is a very rare exception. I've been asked to make an approximation, but I have not been told how many rectangles to use and where to make them touch. But they're testing here, this is a multiple choice question, your knowledge that area under a rate curve gives like accumulated, in this case, cola. So what would I do? I'm gonna have to be very careful about the units. I'm gonna try to figure out what the area under this curve is, specifically from time, so 1 day, that's gonna be hours 0 to 24. I'm gonna make this bigger, and that'll help a lot. Okay. So here's what I'm gonna do. Again, they want a very round number. So I'm gonna try to figure out how many of these rectangles fit under that curve. So there's one rectangle, two, this whole rectangle fits, this whole rectangle fits. These aren't rectangles like our RAM rectangles because they don't go from the input axis all the way up to the top. So it's more like I'm trying to figure out how many boxes fit. That whole box fits. So 1, 2, 3, 4, 5, 6 whole boxes fit. Maybe this and this together make a 7th box, and this together make an 8th box. So they drew those lines in there specifically to help us make this computation. So about 8 boxes fit in, but so let's figure out what the units on each one of those boxes is. It looks like each box is 6 hours wide, 6 hours, and each box is 100 tall. But what are the units on the axis? We were told that that's measured in thousands of gallons of cola, so thousands, and that's gallons per hour. And I have 8 of those boxes that fit. So I'm gonna have 8 times 6 times 100,000. And the units are hours times gallons per hour. It's gonna give final units of gallons. So 8 times 6 is 4,800. 4,800,000 gallons. Let's apply that same principle here. You might recognize part of this problem from your most recent test. If I have a hot air balloon is expanding as the air inside heats up, the radius of the balloon, which I'm going to call r, is a function of the time. So how long the radius of the balloon is depends on how much time since you started heating it up. I know from 0 to 12, r is concave down, and the table gives selected values of r prime, the rate of change of r. So this is use an RAM approximation to find out how much the radius of the balloon changes over the intervals 0 to 12. Indicate units with your answer. So I haven't been asked how to find distance traveled. This isn't a distance and velocity problem, but I can still find out how much something changes by finding the area under that derivative curve. So I can find out how much r changes by finding the area under the r prime curve. So that's what I'm going to do. I don't have an exact value. I don't have a function here. Besides, I don't know that part yet, how to get an exact answer. So the best I'm going to be able to do is make an approximation. And we're going to check. We have very specifically been told where to make our rectangles touch. Oh my goodness. I modified this problem, so it's my fault that I didn't tell you exactly how many rectangles to use. On the AP test, they will always tell you. Use an RM approximation. I will say, let's pretend that I said use an RM approximation with intervals suggested by the table. That means we're going to use 1, 2, 3, 4, 5 rectangles to cover those separate intervals and indicate units with your answer. So here we go. Maybe I'll figure out my units first. Every time I have a rectangle, I'm going to figure out the difference between those two numbers, but both of those numbers are measured in minutes. So my width of my rectangle is going to be minutes. It's going to get multiplied by feet per minute, units of feet per minute. So the units on my answer, the minutes and the feet per minute are going to cancel. My units are going to be feet. And that makes sense because a radius is measured in feet, so we can figure out how many feet difference between the original radius and the ending radius. That's the answer to their question. That's how much the radius has changed over this time interval. So now I just have to figure out the width and height of the rectangles I'm going to use. So my first rectangle covers time 0 to 2. So the width of that rectangle along the t-axis is going to be 2. The height of the rectangle is going to be the output value at the right-hand side of that interval. R for right-hand side. So from 0 to 2, the rightmost number in that interval is 2. I'm going to use the 2's output value. So 4.0 plus. My second rectangle covers from 2 to 5. So how wide is it? It's 3 minutes wide. The height I'm going to use is the output value at the right-hand side of the interval. So in this case, the right-hand side of the interval 2 to 5 is 5. The output at 5 is 2.0. My third rectangle covers from 5 to 7. That's a distance across of 2. I'm going to multiply by the output value at the right-hand side of the interval, in this case 1.2. My next rectangle covers from 7 to 11. That has a width of 4 minutes. Has a height of 0.6. And my last rectangle covers from 11 to 12. That's only a difference of 1 minute and has a height of 0.5. Can I just encourage you right now, maybe on the AP test you will need to use this answer in some other, like part B or part C. That's fine. But just leave this answer here unsimplified. You've made no errors simplifying it. Give units of feet right after it, feet. That's an appropriate answer. If you need a value to use in a problem later on, in that next part, stop and figure this out. So that's going to be my final answer. I'm going to leave that there.